Coastal and Marine Research Laboratory from FORTH presents the Coastal Crete Oil Spill Response Digital Twin, powered by the Iliad Digital Twin of the Ocean Project. Marine oil spills in the Cretan Sea pose a significant threat to marine biodiversity, coastal communities, and local economies. Traditional detection and response methods are reactive, time-consuming, and often lack the accuracy and speed required for effective intervention. There was a pressing need for a predictive, automated, and user-friendly solution. The Coastal Crete Oil Spill Response Digital Twin delivers that solution. It's an end-to-end system that combines early detection, trajectory forecasting, and on-demand simulation capabilities to provide a real-time operational response to oil spills in the Cretan Sea. The system integrates satellite-based detection using Sentinel-1 images, high-resolution atmospheric and sea state forecasting from local WRF, NEMO, and WAVEWATCH III models, and the MEDSLIC2 oil spill simulation software. An AI-based oil spill event detector triggers the simulation workflow, providing short-term forecasting of spill trajectories and fate in near real-time. Users interact through a streamlined interface. Oil spills are detected, forecasts are triggered, and results become immediately available via visual tools and APIs. The system is designed to be used by emergency responders, port authorities, and environmental agencies in just a few steps, reducing critical decision-making time. All components have been Dockerized and shared as applications in the Innesctech registry and open access platforms GitHub and Docker Hub. With a single command line, users can initiate a full simulation. For easier adoption, especially among non-technical users, a front-end tool with drop-down menus and input boxes was developed to construct these commands without back-end interaction. A demo showcasing the usage of the Coastal Crete Oil Spill Digital Twin follows. Users can access it through Iliad Marketplace, where its page hosts detailed instructions and links for data access, discoverability, and even replicability of the pilot, as well as tutorials on how to use the APIs. Associated products from Iliad can be found, as well as screenshots of the tools. An all-in-one web page tool is accessed through the green button at the top right of the page, where users are offered multiple functionalities. Firstly, the option to access the Atom UI and visualize the high-resolution models. After logging in, users have access to wave and hydrodynamic forecasts around Crete in a 1-kilometer resolution, as well as data-assimilated 3-kilometer resolution atmospheric forecasts. Also, users can access time series data at points of interest. Returning back to the pilot webpage, users can input credentials, select point source or satellite-based spill initiation, and other spill parameters like date, duration, and quantity. Lastly, they can select high or low resolution if the spill falls within the bounds of the Cretan Sea domain and insert the relevant credentials. The system then outputs the single command that can be pasted into any Docker-enabled command line prompt. This initiates an oil spill identification using a UNet neural network and a spill forecasting simulation powered by MEDSLIC2 software. Lastly, there is the green button where users are redirected into GeoMachine Relevant Visualization Engine, where the user inputs the file generated by the spill simulation and the visualization is automatically generated. The time dimension is progressed via a drop-down menu, and the oil concentration can be seen at each point by clicking on the map. GeoMachine offers a range of customizable visualization options, including the ability to switch between different map presets such as satellite imagery, overlay low-resolution bathymetry layers, and adjust the color of the oil spill for improved visibility. As illustrated in the example below, satellite imagery captured on July 27, 2023 detected a minor oil leak from a vessel off the coast of Crete, demonstrating the system's capability to identify and visualize real-world incidents. An interoperability challenge was to merge this solution with the OGC API processes to initiate a simulation directly within GeoMachine and run on the background on a dedicated cloud server. Users can now select Run with Edito and set parameters and Run option. Then, They can select on a map a point location or a satellite bounding box, and the respective fields will be automatically filled. Then, selecting spill duration and spill tons and pressing the Run button, they are prompted to wait until the whole pipeline is executed. After a while, depending on the load of the server and the allocated resources, the results are automatically pulled for visualization in GeoMachine, where they are also stored for future investigation. The last functionality of the digital twin we present is an interactive oil spill visual tool which gives an immersive view of the incident and its forecast to the responsible authorities and stakeholders in a 4D environment with alternating metocean conditions. What makes this digital twin innovative? It seamlessly integrates automation, localized high-resolution forecasting, and user-friendly interface design to deliver actionable environmental intelligence. The system eliminates the need for technical expertise in running simulations while preserving scientific accuracy and robustness. Following presentations to the Port Authority of Heraklion, local shipping companies, and the Hellenic Regional Climate Authorities, user feedback, particularly concerns about the complexity of command line tools, prompted the development of a web-based interface. This new interface allows users to configure simulations through graphical inputs, generating a single, copy-paste command to run complex code effortlessly. This approach significantly lowers the barrier for non-specialist users, broadening the platform's accessibility and encouraging wider adoption as we continue to refine the oil spill forecasting service. Discover more at the Iliad Marketplace. The Coastal Crete Oil Spill Digital Twin is more than a scientific platform. It is a practical tool for safeguarding marine ecosystems. We invite public authorities, investors, and environmental organizations to collaborate with us in scaling this solution.